Okay, so R has all these great influence measures that it does by default, and you can just do !influence.measures to see them and get the help file. So there's the standardized residuals, which is residuals divided by their standard deviations. Studentized residuals, standardized residuals divided by their standard deviations, where the standard deviations are calculated in a different way so that the studentized residuals follow a t-distribution. Hat values are measures of leverage. The DF fits are measures of influence of a point on prediction. DF betas are influence of a particular point on the coefficients. Overall change, Cook's distance is a measure of the overall change in across all covariates. And DF betas, I think I misspoke when I said that DF betas looks at individual covariates, where Cook's distance looks at all the covariates, kind of organized in the right way. There's a little typo there that I got to fix. Resid returns the ordinary resid here. This guy returns the ordinary residuals. And then this guy, if you just take resids and 1 minus the hat values, I noticed R doesn't do this automatically, but it's so easy, why would you care? Where fit is the linear model fit, that returns the so-called press residuals, okay, which are the leave one out cross-validation residuals. And so what I mean by leave one out cross-validation residuals, I mean the difference between the observed data point and the fitted data point, where the model was fit without that data point being included in the model fitting. So that's kind of like, I left out this point and now I want to see how my model predicts at this one point, and by maybe leaving one point out, I'm not going to impact how well I estimate the model, but now I have kind of a pure measure of prediction error. And there's lots of cross-validation strategies. I think you'll cover them in your machine learning class if you take the series. It is neat. I find it neat that you don't have to actually take out the point and refit the model to get these leave one out cross-validation residuals. That's a nice component of linear models. It's neat, I think. The proof is really neat too, but it's probably a little bit beyond the scope of the class, and we don't want to spend a week just going through the proof of how you get the press residuals. So how do I use all these things is probably what you're asking yourself. And the number one rule, I would say, is be wary of simplistic rules for diagnostics plots and measures. And I prefer to think of these tools as being context specific. So what I would hope everyone in this class would do is understand what the tools are trying to accomplish and to use them judiciously and smartly. And a very important point is not all the measures have meaningful absolute scales. So you might want to compare certain measures of outlierness or influence or whatever across different data points, but you don't want to compare them across data sets. But what they do is each in turn is they kind of probe your data in different ways to diagnose problems. Think of yourself as you're a data doctor and you're trying to diagnose something, so you have all these different probes and tools that you're using, and that's what these little diagnostics are for. That's why they call them diagnostics. So anyway, residuals are, of course, the most important component of all the diagnostics, looking at residuals. And basically what you want is no kind of obvious systematic pattern in your residual plots. So you don't want heteroscedasticities, like non-constant variance. You don't want things that show obvious evidence of missing model terms. And you don't want things like temporal patterns. So if you were to plot residuals versus the order in which the data was collected, you don't want things like that. Residual QQ plots, quantile plots investigate normality of the errors because it's plotting the quantiles of the residual versus the theoretical quantiles of the standard normal. Leverage measures can be thought of as diagnosing. Those kind of measure the potential influence for leverage. So they only depend on the x's. They don't depend on the y's. They measure the potential for leverage. And some of the other measures, like the DF betas, measure the actual influence. But nice thing about leverage measures is they can often be useful for diagnosing data entry errors or kind of aberrant points. Influence measures, they get to the bottom line, kind of how does deleting or including this data point impact a particular aspect of the model.